Hey there, it's Jamie and welcome to an introductory video on simple linear regression. In this video, I'm going to introduce what simple linear regression is, showing you how to conduct a simple linear regression in Excel by first making a scatter plot and inserting the trend line to show the line of best fit and its equation, but then we'll also calculate the slope and intercept for that line using the slope and intercept functions in Excel. And then we'll interpret those results by comparing them to our equations for an estimated regression equation. So what I have for data is data from a trucking company, hypothetical data, for 10 deliveries made by this company. For each of those deliveries, I've got two variables, the miles traveled and the time in hours that it took the driver to make the delivery. So let's take, for example, data point 1, our first delivery. That delivery was 100 miles long, and it took the driver 9.3 hours. So for all 10 observations, I have data on those same two variables. So to get started, we want to see how these variables are related, and we're going to do that by making a scatter chart, or a scatter plot. I'm going to hold down miles, or highlight miles, then hold down Command or Control if you're on a PC, and then highlight time in hours. From there, we're going to insert a scatter plot, an XY scatter with the dots, no lines connecting them. And we get a scatter plot that looks a little bit like this. The first thing I do is double check to make sure that I do indeed have miles on the x-axis, and here I do have miles on the x-axis. And then, do I have time on the y-axis? I sure do. And do my points make sense? Well, let's take a look at this point right here. Series, time, y hours, point 100, comma 8.9. And then I can look and see right here, oh look, I've got this point, 100 on the x and 8.9 on the y, is right there in that first point. So our x value is the miles traveled and the y value is how long it took. Let's label these so that if we come back to it later, we'll know exactly what we've done. I'm just going to give this chart the same title as the table, miles traveled and travel time for 10 assignments. Then axis titles on both the vertical and the horizontal axes. We'll give them a label. I've got travel time in hours. And then down here, I'm going to call this miles traveled. Perfect. So our scatter plot gives us a visual representation of the data and the pattern that it forms. We can see that there's an upward slope here, that this data does seem to be positively related. The more miles you travel, the longer it seems to take the driver, and that's the relationship that we would expect. Excel will insert the line of best fit into this data, and we can do that by clicking any one point and then right-clicking on that same point. I'll bring up the second menu, and you're going to add a trend line. This is the least squares regression trend line. This is the estimated regression line, and if we want to see the equation for that line, we can press display equation on our chart. And that equation will pop up here. I'm going to delete these vertical and horizontal grid lines. And now we just see our chart and our equation. It's customary to show a result to 2 decimal places when it's in a chart or in the text, sometimes even to only 1 decimal place. But here, because I've got a result that would be vastly misrounded if I wanted to round it to 1 decimal place, I'm going to round these to 2 decimal places. I'm going to click on it, then right-click, Format Trend Line Label. And I'm just going to call it, under number category, I'm just going to call it a number. And that number rounds to 2 decimals. That lovely equation, that handy-dandy equation, is our estimated regression equation. We can look at down here to see 2 common ways to see this equation, and we can compare them to here. So we've got a line, the equation for a line, in the format of y equals mx plus b, where y is our estimated value for travel time, and that's equal to a slope of 0.07 times x times the miles traveled and then plus an intercept of 1.27. In our regression equation, we can think of that as all of the points that are on this line are estimated values of y. So that is the line of best fit. It only really touches 2 of the points in our data. So if we have an estimated value for x and we plug it into this equation, we'll get an estimated value of y. And that estimated value of y is going to lie on this line. So our estimated value of y is equal to beta 0, which is our intercept, plus beta 1, which is our slope, multiplied by the value of I. So here, if I hypothesize that we're going to make a couple other deliveries, 11 and 12, I'm going to italicize these because they're hypothetical. And then I'm going to say that one of them is 100 miles. Let's just do that one for now. I can forecast or estimate how long it's going to take by plugging in the values of this equation. It would be nice to have these values in the spreadsheet already so that I don't have to type in 0.07 and I don't have to show this for enough decimal places to really get the level of precision that I want. So I'm going to use Excel's functions for slope and intercept to get a value that I can use to estimate the value of y for a given number of miles traveled. So to get the slope and intercept, I use Excel's functions slope and intercept. Slope, it's equals slope, open parentheses. It asks for 2 things, the known values for y and the known values for x. Well, we have those, right? Here, I've got my values for y, and each of these values of y corresponds to one of these values for x. In this slope formula, Excel figures out the line of best fit that goes through those variables, those data points, and then returns the slope. So that slope is 0.068. If I reduce it by a decimal, you'll see that it's 0.07, which is the same thing that's here. These numbers are in fact identical, but I'm going to show one to a slightly larger level of precision. The intercept formula equals intercept. What is the y-intercept of the line of best fit that goes through these data points? Here are the y values for the data points and the corresponding x values for those data points. And our intercept is 1.27, which matches the value that we get on the equation for our trend line on our chart. Well, these 2 numbers are a lot easier to use to forecast the amount of time it's going to take because I can reference them directly. So to estimate how long it's going to take to make a delivery that's 100 miles long, I say that y, our estimated y value, is equal to the intercept plus the slope times our value of x. So let's just enter this. Our intercept, I'm going to command T so that I can use this equation later if I need to, plus our slope multiplied by the value of x we're interested in projecting for. And here we can see that the estimated value of y for a 100-mile trip is 8.1 hours. And that would be the point exactly on this line. And that's why we call it the estimated value of y. In fact, for any value of x that we put into this equation, we're going to get a point that's exactly on this line. All right, let's come back for the next video to talk a little bit more about how we interpret this slope and intercept, how we would discuss it if we were trying to write a little blurb interpreting some results that we have. See you soon.